Hello everyone. Today I will present you the regional impact of two major green initiatives that are taking place in Northern Africa and Middle East, and its a reciprocal influence. The presentation is divided in three main parts. The first one, I will be focusing on the introduction about the two green initiative, then I will be discussing the experimental design, and then I will dive into the result. The first idea of the Great Green Wall dates back actually to 1935 when the English forester Stabbing proposed a forest belt between the Sahara and the Sahel to reduce the southward advance of the desert and man-made soil erosion. The idea of incorporating trees as useful infrastructural elements in the landscape in the Sahel and the Sahara arose as early as 1960, but till then were just at the beginning of the 80s. Thomas Sankara, the leader of Burkina Faso, initiated a massive reforestation campaign, and over 15 months his government planted 10 million trees to fight desertification and restore the environment. This became one of the most iconic environmental achievements, part of his broader One Village, One Groove initiative, encouraging each community to revive ancestral tree planting tradition. Unfortunately, Thomas Sankara was assassinated in a coup in October 15, 1987, which was orchestrated by his former ally, and who took then power and dismantled many of Sankara's revolutionary programs, like land reform, vaccination, literacy, women's empowerment, and also reforestation. In 2005, eventually the proposal was revived by the Nigerian president, Obasanjo. In 2006, the Great Green Wall is approved by the African Union, and then eventually in 2007 was officially adopted. The Great Green Wall is a multi-billion-dollar African initiative based on the afforestation of about 7,000 kilometers long stretch of degraded land that goes from Senegal in the West Africa to Djibouti in the east. The objective is changing the hydrological cycle in order to increase local rainfall and combat desertification and droughts in the Sahel. This region, as you may know, was ravaged by severe droughts during the 60s and 70s and represent an important climatic hotspot which affects the local community. So the initial idea of planting a wall of trees at the border with the Sahara has been replaced by a more feasible initiative, an integrated ecosystem management approach, which consists of a mosaic comprised of diverse landscape scale actions that are designed to provide long-term solutions for improving environmental and socio-economic conditions in the zone. For this reason, they are sort of planting trees like the Arabic gum or Acacia Senegal. And here we can see a plot in northern Senegal, which is a pretty dry region, and we can see how it looks when it's sort of regreen. And from satellite, we can see also the plots that have been regreen. And here, the normalized difference vegetation index. We can see exactly where the Great Green Wall plots are. By 2019, about 16% of the Great Green Wall has been planted, including official Great Green Wall intervention and as well as community-led restoration. Now we are between, if you only consider the official Great Green Wall intervention, we are only at 4%. But if we actually consider also the community-led restoration and so on, we are, according to the UN-led estimate, we are about 30%. So the 100% by 2030 seems unlikely, but 14 billion in funding from different nations stakeholders are coming over the next 5 years. In 2021, Saudi Arabia launched another green initiative that's called like the Middle East Saudi Arabia Green Initiative, which is an ambitious regional effort to combat climate change, desertification, and air pollution. The plan includes like a massive 50 billion trees across all the Middle East, of which 10 billions within Saudi Arabia alone, making one of the largest reforestation projects in the world. Beyond trees, the initiative also aims to cut carbon emission from oil production, expand clean energy, and promote regional cooperation. This sort of reflects both Saudi Arabia's vulnerability to climate impacts and its aspiration to lead global sustainability effort. So far, 151 million trees have been planted in Saudi Arabia, which is about 1.4% of the total 10 billion trees. And on the other hand, there is no extensive evidence of large-scale afforestation effort for the rest of the Middle East. However, Saudi Arabia has committed like 188 billions in public and private sector initiative under this Saudi Green Initiative. So in terms of experimental design, for the study that I will be presenting, we have been using two different models: the Global Environmental Multiscale Canadian Weather Forecast Model, GEM, and the US-based Weather Forecast Research Model, WERF. Here we present the resolution of we run the simulation are about like 12 kilometers, and we can see here on the left the GEM domain, and here the WERF domain. The GEM experiment, the simulation, we have like a reference simulation with no gray-green wall for like the present day, and then we run a set of sensitivity experiment for the future, in which we include the greening of the Sahel with the different scenarios: low, medium, high, extreme, and then we also run one case in which is a green wall medium plus the Middle East Saudi Arabia Green Initiative. We run two scenarios for the future, like the two extremes, like the RCP 8.5 and RCP 2.6. For WERF, we run 30 years under present day condition, and we just green, the circle that I showed you before, and we run a case in which we green only, in which that circle area, and any other one in which we green and we also irrigate. So in our study, we follow the Sahel border, in particular the rainfall climatology between 100 to 200, between 200 to 300, and then 300 to 400. And we use we implement a mix of woody and herbaceous species with properties and characteristics similar to those proposed and used in the Great Green Wall. For example, depending on the precipitation climatology, a different mix of desert, short grass, evergreen, and deciduous shrub is used. Here we can see how the vegetation has been instead altered based on the amount of annual precipitation here in this table here, and the area that should be covered is about 1,300,000 square kilometers. So we have been starting planting with different as shown here in the table, and the Saudi Arabia accounts for about like half of this total area. In the WERF experiment, we only changed the vegetation in the region circled here, and we're getting about 30% of the vegetation in the area, and it's a mix of trees and grass. Okay, let's now dive into the result related to the Great Green Wall. Here we compare the present day 1991-2020 with the last 30 years of this century under RCP 8.5 and 2.6 scenarios, and we can see here the change in precipitation anomalies without considering the Great-Green Wall, and we can see much of the changes. So if you look at the rainfall anomalies associated with the Great-Green Wall, on top of those just due to the greenhouse gases changes, we can see a notable increase in the amount of precipitation falling over most of Northern Africa, and particularly when we go with like an extreme case. In the extreme case here, we can clearly see that the precipitation extends well outside the wall. And here is for the other scenario, and we can see that it doesn't matter the scenario, the effects are very. So if you look at the temperature anomalies just due to the greenhouse gases, we can see that in the RCP scenarios, the changes in temperature are like around 1 degree, but in the case of the RCP 8.5, we get like an anomaly of up to like 5 degrees. Then if we consider the Great-Green Wall, just we are looking at the summer, well then when we start greening, then we have a cooling during the summer, and we can see that the anomalies are very similar if we are in the RCP 2.6 or in the RCP 8.5. We then look at some extreme quantities like the consecutive dry days and other. So meaning like the consecutive days with precipitation below 1 millimeter, they give us an idea, like an indication of the length of the droughts. So the changes are not too significant for the consecutive dry days across the domain in either of the scenario, but when we consider the Great-Green Wall and the extreme Great-Green Wall case, we can see a reduction of consecutive dry days along the Sahel and also part of the Sahara. So which means that we are reducing the length of the droughts. And you see that the pattern is very similar in the two scenarios. Here we then look at the change in hottest temperature. We did see like a decrease in the temperature during summer, but what about the hottest temperature? Well, actually we can see an increase that is larger with the scenario with more vegetation. However, we can see that the anomalies are strictly confined to the Great-Green Wall, but are of the order of 1.5. So why is this the case? This is the case because of the change in albedo, and this extreme in temperature are recorded in the pre-monsoonal season. Let's now talk about like the Middle East Saudi Arabia Green Initiative. Here we can see some preliminary result based on 10-year simulation of my master student. Here we can see the climatological annual mean temperature for the control and future scenario and the Middle East Saudi Arabia Green Initiative, Middle East Saudi Arabia Green Initiative plus Great-Green Wall. And then we can see now the difference on the left of the future relative to the control, and then the Middle East Green Initiative future minus the future with no change in vegetation, and the combine of the two initiatives like the Middle East and the Great-Green Wall minus the future. We can see that the vegetation increase the temperature, but when the two are combined, the increase in temperature is less intense. So and then here for precipitation we can see that when we combine that we look at the annual precipitation, where we combine here the two initiatives, actually the effect are even amplified over the Middle East, and we can see here in percentage, and we can see it better down here. Yeah. When looking at rainfall, I just wanted to show you the consecutive dry days, the climatological one, and the differences, and we can see that the Middle East Green Initiative decreased the length of the droughts, but when combined with the Great-Green Wall, the consecutive dry days dramatically decrease. So how does it work? Why the Great Green Wall is actually leading to this effect on the Saudi Arabia? We are investigating that, but I mean, it seems like that the decrease in the albedo over the Great Green Wall causes a warming over Northern Africa, which give rise to an anomalous low-level cyclonic flow here, which enhances the mid to upper level westerly, bringing more rainfall over Saudi Arabia. Finally, in the last study, we look at the role of vegetation just over central Saudi Arabia alone and in combination with our irrigation. When we say irrigation, we are talking about like 0.5 millimeter per day at sunrise over 1 hour, like around 6 a.m. for the first hour till 7, we provide about like 0.5 millimeter of water. We can see that the warming here is the anomaly, in the case of deforestation minus no afforestation, and we can see that there is a warming, and then when we actually start with the irrigation, we actually get a cooling. In terms of precipitation, it's interesting to see the increase in precipitation, which is restricted only to afforestation area, almost when we only have afforestation, but when we also provide irrigation, then the anomalies is strong enough to actually get significantly rainfall anomalies well outside the reforested area. So in conclusion, the Great Green Wall has a significant impact on Northern African climate, increasing rainfall over the entire Sahel and even doubling the precipitation in its northern side. The consecutive dry days are substantially reduced, and also I didn't show, but the max 5 days precipitation are also increased in equatorial and tropical Africa. The temperature around the Great Green Wall are decreased of up to 1.5 degrees during the summer, during the monsoon season, and over 2.5 in the case of the extreme scenarios. However, hotter temperature become more frequent along the vegetated area up to 1.5 degrees. The Middle East Green Initiative increases the precipitation, and the consecutive dry days are also substantially reduced in the green area, in particular when in combination with the Great Green Wall. The temperatures are increasing in the forested area. However, if irrigated, the evaporation cooling offset the warming due to the albedo change, but then there is the heat stress, so the increase in humidity that needs to be accounted for, and that we are working on calculating actually exactly that to get a better idea of the heat stress due to the regreening and irrigation. That was it. Thank you for your attention.